Hello everybody, and welcome to the continuation of example 3. We are looking at page 6 of the workbook here. And before we start into this, notice that at the top of the page I just kind of wrote some of the information down again that was given to us in part A, just so that we don't have to keep flipping back and forth between pages. Okay, so part B would like us to evaluate the difference quotient from part A for two values of h equals 4 and h equals 2. All right, so let's do the calculation for h equals 4. So here's our difference quotient, and they're really just asking us to substitute 4 in for h. Okay, so if we do that, we're going to get f of 1 plus 4 minus f of 1 over 4. And here's the thing. We could do that calculation using the function f, which we know. Okay, f of 1 plus 4 and f of 1, we could use that formula to calculate those, no problem. But if we did it that way, we'd essentially be redoing the work that we did in part A. In part A, we already calculated the difference quotient, and we came up with negative 7 over h plus 3 for it. So it's shorter just to use this formula up here, okay, and substitute in the value of h there. And if we do that, what we're going to get is just negative 7 over h, which is 4, plus 3. Okay, notice that that's negative 7 over 7, and so numerically we're going to get an answer of negative 1 there. Okay, what about h equals 2? Well, same idea, just that we're substituting in a different value of h. Okay. And if we go up to our formula again that we got for the difference quotient, we're just plugging in h there. We're going to get negative 7 over 2 plus 3. And if you do that calculation, you're going to get negative 1.4 out of that. Okay, now what do those two numbers mean? Okay, could we make sense out of those in the context of the problem? Okay, well there, we want to go back and maybe remind ourselves what the difference quotient was that we were calculating. Okay, remember way back in the beginning of part A, we noticed that the difference quotient is a change in volume over a change in time. Okay, so if you think about units there, that would mean that our difference quotient has units of gallons per minute. That has to be the units on these two numbers that we're getting here. Gallons per minute and gallons per minute. And so conceptually, we can think of those as being leak rates. Okay, negative 1 gallons per minute is the leak rate between, now the question is between what times? Well, we can look here and see what the times are. We're going between 1 plus 4, which is 5, and 1. So between t equals 1 and t equals 5 minutes. Okay, and then similarly, negative 1.4 gallons per minute, that's the leak rate between 1 and 3, if we look at the two time values that we're plugging in. Okay, now we could even ask the question, do those answers make graphical sense that we just came up with? So these average rates of change can be thought of as slopes. Okay, so if we take the negative 1, for example, okay, that should be the slope of the line segment on our graph between t equals 1 and t equals 5 minutes. Let's draw that in. Okay, so I'm going to find the points at 1 and 5. And if we draw a line segment, its slope should match that leak rate. Okay, negative 1. Okay, and we can do the same thing with our other answer. Okay, this negative 1.4 that's sitting here, that should be the slope of the line segment between t equals 1 and t equals 3. Okay, so if we find those 2 points, that would be from here to here. Okay, and that slope would be negative 1.4. Notice that you can graphically see that we're getting a steeper slope between 1 and 3. And that's just telling us that we're getting a faster average leak rate, okay, between those two times. Okay, and I think we've finished with part B.